and today I'm going to be showing you a distance of a projectile. So, okay, so let's just get right into it. So, what do I mean by the distance of a projectile? Well, let's say that you have let's say you have a cannon, and let's say this cannon fires, I don't know, a ball at some speed. So, let me just okay. So let's say you have a cannon and it fires let's say a ball at some speed s, and let's say that it is launched with respect to the ground, like this. Right, that's the ground. If that's the ground, we have an angle, theta, that is the angle between the ground and the launch angle. And we're going to call that theta for this video. Okay? Okay, so what I want to do is let's first draw the trajectory of this cannon. Well, it's going to be like this, right? Or something like that, right? So it's going to hit maybe around here. Now what I want to do today is I want to find what this distance is. This distance from here to here. So what is this distance right here? And let's call this distance d. Okay? So if we call this distance d, how do you figure out d in terms of what I've given you here? Well, I'm going to let you think about that for a second. Why don't you pause the video and figure it out? Okay, so I'm assuming you paused the video. If you haven't, please pause the video right now. If you have, well, I hope you noticed that. Okay, I'll just tell you the answer. Okay, so first step is to figure out what the components of launch velocity are. So what we're going to use is we are going to use the formula. We're going to use the formula distance equals rate times time. Okay, so we have to figure out the time it's in the air and the rate it's traveling at. So so how do we figure that out? Well, first of all, let's break up this s speed into its horizontal and vertical components. So what's its vertical component? Well, that is this length right here, right? So that is the vertical component. So basically we're dropping at a perpendicular, so this is a right angle. Okay, and so that is the horizontal component of s, so the vertical component of s, so I'm gonna call that the SV, or S vertical. Now what we're gonna do is we are going to find the other length, this length. Okay, so what is this length? Well, that's going to be the horizontal part of S. So let's call that, S horizontal. Okay? So if we call that S horizontal, how do we use these to figure out the rate and the time? Well, the rate is pretty easy. It's just going to be this, right? But what is this? So to figure that out, we are going to assume that we know the angle theta and the length s. Okay? And so how do we figure this out? Well, we figure this out by using trigonometry. So let's write down SOHCAHTOA just because. SOHCAHTOA. This basically says that sine is opposite over hypotenuse, right? Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So katoa. Now, which one? So if we know the, I guess the hypotenuse and the angle theta, how do we figure out these two lengths, SV and SH? Well, okay, so let's try and figure out the SV first, okay? So if we figure out SV first, whoops. So let's try and figure out what SV is, or S vertical, okay? So S vertical equals what? Well, we can use this first thing of katoa, which says sine is equal to opposite over hypotenuse, right? So we know what sine of blank is, theta, I guess, and the hypotenuse, so we just have to solve for the opposite side. So what's opposite theta? Well, it's going to be S vertical, right? So let's put that into equation. Sine of theta equals opposite, the S vertical, divided by S, because that is the hypotenuse. Okay, so what is this? Well, let's solve for SV. So if we multiply both sides by S, we get S sine of theta equals SV, right? Okay, so that means SV equals S sine of theta. Okay? So we found out what SV is. Now let's figure out what SH is. So what is SH? What is SH equal to? Well, again, we can just use our trigonometric functions. Ka works because cosine is adjacent over hypotenuse. The adjacent side here is SH, so that'll work. So that means that cosine equals adjacent over hypotenuse, right? Okay, so how do we figure this out? Well, we can just scroll over a little, and a little bit down. Okay, so again, we can just do what we did last time. So cosine of theta equals adjacent. Adjacent is the, what is the adjacent side? Well, the adjacent side is SH here, right? So adjacent is S horizontal over S, right? Because that's the hypotenuse. Now let's simplify this by multiplying both sides by S. No, not 2S, sorry. My head's stuck with 2 for some reason. So that means that S cosine, what a horrible, cosine of theta equals S horizontal, okay? Or speed horizontal, the horizontal speed. So now we have two equations that give you both the horizontal speed and the vertical speed. So the horizontal speed is S cosine of theta. And yes, I am covering up the D. Okay, anyway, so now we can start spray paint. We can start figuring out what D is. So now we know the rate. We know the rate as S cosine of theta. Now we have to figure out the time. So how do we figure out the time, or what's called hang time? So how long it's in the air. Well, let me give you an example. Let's say that you throw something upwards, directly upwards, at a speed of 10 meters per second. And let's say surface gravity on your planet, wherever you might be. Probably Earth, but I can't rule out the moon or Mars. Whatever your gravity is, let's say your gravity here is 10 meters per second squared. That's approximately Earth gravity. I just round it because Earth gravity is equal, well, this is roughly equal to 9.81 meters per second squared. So I just round it to 10. Okay, so how long is this going to be in the air? If we assume that it's going to be 10 meters per second and you throw it at exactly 10 meters per second squared. 10 meters per second and gravity is 10 meters per second squared. So it's slowing it down at 10 meters per second squared. So, okay, so in the first second, it's going to go up in 1 second, right? But then it's going to stop because the 10 and the negative 10 cancel out perfectly. So it's going to stop, and then it's going to start accelerating down in 1 second because it's the same distance, right? So then it's going to hit the ground. Plop. Okay. So that is our motion. So what do we do now is we add up the two distances, or 2 seconds. So it's going to be in the air for 2 seconds. So another way of putting this is we can say that it's just 10 meters per second, how fast you throw it, over the gravity. 10 meters per second squared. But this is only going to give you the upward velocity. We want to multiply this by 2 because it's going to take exactly the same time, assuming no air resistance. So yes, so this is basically the equation. Now, you could have just written 2 seconds here, but this formula here gives us a general reasoning for how fast how long something is going to be in the air given the surface gravity and how fast you throw it up. So in our example, remember our example right here. Don't forget our example. That's the most important thing about this video. Let's see. So what is going to be hang time, or I'm going to call it TA because TA is time in the air. So TA is going to be equal to what? So we figured out that it's this. So it's going to be how fast you throw it up. So speed vertically divided by, what is it? G, or gravity, the gravitational constant, times 2. So that is our equation. Now, let's apply this formula here to our equation. Now, this looks like as simplified as it can get, but look, SV here is the same thing as S sine of theta. So let's just write that in. So let's say that here, TA equals S sine of theta divided by 2. Okay? So now what we can do is, multiplied by 2, of course. Now let's move this 2 up to the denominator here, okay? And move it in front, because this will just make it easier for us to calculate later. So let's just move it up, and let's do it over here. Oh, no, that's the end of the screen. Okay, so we can just, I don't know, we can just spray paint this out. It's kind of an eraser. I guess this is a better eraser. There we go. Okay, everything's gone. Okay, so what do we do now? What we can do is we can just take that formula. What was it? Oh no, I'm drawing in white. TA for our example is going to be equal to 2S S sine of theta divided by 2, divided by g times 2, okay? That is our equation that we just derived. Okay, so now this is where d equals rate times time starts to come in. So what is the rate? Well, the rate is just going to be the horizontal speed. What is the horizontal speed? Well, we already figured that out. That's s cosine of theta, better known as sh, but we're going to use this. So let's write down our equation. Okay, so distance, this is what we're trying to figure out, and this is kind of the home stretch here, is equal to the horizontal rate. What was that? Well, that was s. Let me just change colors here, just so it looks nice. For no reason, yep. Totally, I love doing things for no reason. Distance equals s cosine of theta multiplied by the time. Well, what's the time? We just figured out the time. This is that. Oh, actually, we should get rid of this too. Sorry about that. Yes. So because we already moved this 2 up here, right? So, okay, so let's put this formula in. Times 2s sine of theta divided by 2. No. Now, why do I keep thinking about 2 for some reason. The number 2, okay. G, okay. So this is our formula. How the heck do we simplify this thing? Well, okay, so here's a very easy way to simplify it. Now, all this stuff here is actually supposed to be above the radical. So it should be like that, and everything should be divided by g. So we can rearrange this. Let's rearrange it as d equals s cosine of theta times 2s times, I'm writing the times in here, 2s times sine of theta, right? Okay, so now we have our thing. Oh yeah, divided by g. Divided by g. Okay, so now we have our equation. Now let's combine like terms. So we can combine the 2 cosine and sine. Well, we can't technically, but we can combine the s and the 2s, and we can just divide that by g. So let's simplify this too. D equals s times 2s is going to be 2s squared, right? And then we're going to divide that by g. And then we're going to multiply this by cosine of theta times sine of theta. And there we go. We have our equation. This is our distance. Now, here, let me just write it again over here. Here we go. So, distance equals 2s squared divided by g times sine of theta times cosine of theta. So here is our equation. Now, what do we do here? Well, we can just take this and we can just take this and just insert our things. So for example, you have to just tell me the speed it's launched at, the gravitational constant, and the launch angle, and I will give you the distance here. That is awesome. So that is all that I have to show you. Thank you for watching. I hope you liked this video. If you did, please subscribe, like, and share this channel with others. Also, please remember to subscribe. Thank you for watching. Hit that thumbs up button if you really like this video. See you at howtodoethathan.com, and see you next time. I have so many things to say. Bye.